So this question is calculating an equilibrium problem from a partial equilibrium something something something. I don't quite know what the end of the problem is, but it looks like we're going to have to calculate an equilibrium constant. And so it says sulfur dioxide and oxygen gas react to form sulfur trioxide during one of the key steps in sulfuric acid synthesis. So I would go ahead and get a balanced equation for that. So SO2 plus 2 give SO3. So it looks like I'm going to need 2 of those, and then I'm going to get 2 of those, and then now everything balances. It's all about the oxygens, right? 2 sulfurs, 4 plus another 2 oxygens, 6 oxygens on the left, 6 oxygens on the right. Okay, and everything's in the gas. So there's my balanced equation, and looks like I'm going to be working in ATMs here. So let's just see. An industrial chemist studying this reaction fills a 2-litre flask with 4.7 ATM sulfur dioxide gas and 2.2 ATM of oxygen gas. Okay, so there's no SO3 to begin with. And then when the mixture has come to equilibrium, measures the partial pressure of sulfur trioxide to be 2.6 ATM. Calculate the pressure equilibrium constant for the reaction of sulfur dioxide and oxygen at the final temperature of the mixture. Round your answer to 2 significant figures. Okay, so I kind of know what's going on here. So we're going to calculate Kp, all right? So we need to be working in ATM because it's a Kp. So initially we have 4.7 of that, and we have 2.2 of this, and we have 0 of that. And then the change is, well, this is going to go up by 2.6. And then now you see how these guys have the same coefficient. That means that the SO2 is going to go down by 2.6. And then we can see here that for every 2 moles of SO2, we only use up 1 mole of O2. So O2 is going to go down by 2.6 on 2. So when we come to equilibrium, 4.7 minus 2.6 would give me 2.1. 1.2 minus 2.2 minus 1.3 is going to give me 2.2 minus 1.3 is going to give me 0.9. And then this is going to be 2.6, which we already knew, right? So these are my equilibrium amounts that I can go ahead and use to calculate my Kp. So I should write out my Kp expression. Kp is going to be the pressure of SO3 squared over the pressure of SO2 squared multiplied by the pressure of O2, and that's just to the power of 1. Now I want to make sure that that whole bottom line is in parentheses. So this is just going to be 2.6 squared over 2.1 squared times 0.9. And so in the end, so K's are always unitless, but we want this to be to 2 significant figures as asked in the question, and we'll see what we get there. And so it ends up being, when I do that, was I got an equilibrium constant of 1.7 to 2 significant figures. Okay, so that's it. Kp is 1.7. Just check my sig figs, 2 significant figures. Okay, all makes sense to me. Unless I've made a typo on the math, that should be it. I'm just going to put that answer in one more time. The math at the end there. Yep, no, definitely 1.7. Okay, so that's it. I hope it helps. I think the first point is getting the balanced equation, and then secondly, setting up the ICE table to get your equilibrium amounts. Okay, have fun with that. Bye.